Today we are going to learn about the Sokotowa concept. This comes in the basic trigonometry. All these calculations are associated with the right angle triangle. So let me draw a right angle triangle. Consider this to be ABC right angle triangle with the angle theta. So this is going to be opposite. AB is going to be opposite. I would say O. CB is going to be adjacent. I would say A. And then AC is going to be hypotenuse. So it's going to be H. So the basic Sokotowa concept is this: sine theta. So here it should be an angle, should be equal to opposite divided by hypotenuse. So this is the definition. So opposite is going to be O, hypotenuse is going to be H. So that's how we have SOH concept. So S is coming from here, O is coming from here, H is coming from here. Okay, so let's go with cos theta definition now. So again, inside should be an angle, inside should be an angle, and that is equal to adjacent divided by hypotenuse. So we call it A divided by H. So that's why we got CAH, as we can see in here. Now we will try to understand the tan. So tan theta is equal to opposite side divided by adjacent side. So O divided by A. So that is TOA, TOA term. So this is how we define basic trigonometric identities. Now I'm going to discuss a few examples here. So in this example, I'm going to say my hypotenuse is R, my angle is theta. So height, I'm going to say X, this height, and the length I'm going to say Y, right? So the question is, write X and Y both in terms of R and theta. This is a question. So what we do is, to find X, we define sine theta. So that is going to be X divided by R, opposite divided by hypotenuse. So from here you subject X, and that X is going to be R sine theta. It's going to be R sine theta. Similarly, cos theta is Y divided by R. So Y is going to be R cos theta. So what we did was we cross multiplied this in here. So that way you can isolate X and Y. So when we have a diagram like this, then right angle triangle. So hypotenuse and the angle alpha is given to you in this case. So you can write the opposite to be R sine alpha in terms of R and alpha. Then other one you can write as R cos alpha. This is how it works. Now let's think about this example. Suppose this is theta. Hypotenuse is R, right angle triangle. This I'm going to write as R sine theta. Then adjacent side I'm going to write R cos theta. Now I'm going to use Pythagoras theorem here. I would say P theorem. So if I use P theorem here, I get hypotenuse squared is equal to opposite side R sine theta, the whole thing is squared, plus r cos theta squared, and then that's Pythagoras theorem we applied. Now we will simplify this a little bit. So it's going to be r squared sine squared theta plus r squared cos squared theta, and this is r squared. So now I'm going to factorize r squared. So it's going to be sine squared theta plus cos squared theta, and then you get r squared here. Now you can see r squared gone, right? So we comment here r is not equal to 0. If r is equal to 0, you can't cut like that. So then if you do so, you get 1 is equal to sine squared theta plus cos squared theta. Right. So this is very important relation, or we call it identity in trigonometry. Let's think about another example of that. So use sine squared alpha plus cos squared alpha is equal to 1 identity. So we'll think about few examples, right? So it's going to be sine squared 45 degrees plus cos squared 45 degrees also 1. Sine squared 30 degrees plus cos squared 30 degrees also 1. Similarly, sine squared 60 degrees plus cos squared 60 degrees also 1. Right? So the lesson is, doesn't matter what angle you put here, this relation will give you 1 as the output. Also, one important note here. So most of the kids are confused with this one. Sine squared theta means sine theta, the whole thing raised to the power 2. This is sine squared theta. This is nothing but sine theta multiplied with sine theta. Example, if you have sine squared 45 degrees, then this is going to be sine 45 degrees, the whole thing raised to the power 2. This is equal to sine 45 multiplied with sine 45. So we know that sine 45 is equal to 1 divided by square root 2 multiplied with 1 divided by square root 2. Finally, you get the answer 1 divided by 2. Let's think about a question where ACD is a right angle triangle and BCD also a right angle triangle. So BCD is inside ACD right angle triangle, and the details are shown to you. The height is h, and BC length is x, and AB length is y. The angle A is theta, angle B is alpha. So the hypotenuse is not given to you, and the BD hypotenuse is also not given to you. So we'll try to find out these details using SOHCAHTOA concept. So this is a practice question. Let's think about BCD triangle. Okay, I would say BCD right angle triangle. So if you use that triangle, so you can say, you can define sine alpha, obviously. You can define cos alpha, obviously, and then tan alpha. Okay, so sine alpha is equal to h divided by, right? H divided by, we don't know the hypotenuse, right? Cos alpha is equal to x divided by, we don't know the hypotenuse, that would be BD. Tan alpha is h divided by x. Okay, so now how do you find BD hypotenuse? So we can use Pythagoras theorem. So if you use Pythagoras theorem to BCD triangle, so it would be BD squared is equal to x squared plus h squared. So from here you can find BD, which is x squared plus h squared square root. So that would be this x squared plus h squared square root, right? Okay, so from there you can find sine alpha. So now sine alpha is going to be h divided by hypotenuse, which is going to be x squared plus h squared square root. Then cos alpha you can find, which is going to be x divided by hypotenuse, which is x squared plus h squared square root again. Okay, so that's done. Now what we can do is we can consider ACD right angle triangle. So I'm going to use this AD now using Pythagoras again. So if I do that, I'm going to do that in here. So AB squared is equal to AC is going to be x plus y, the whole thing squared, plus h squared, right? So AB now you can find, that's going to be the square root of this term. Okay, square root of that term. Now we have AB in terms of x, y, and h, which are the given details. Now we will try to find out sine theta. So sine theta is going to be opposite, which is h, divided by hypotenuse, which is AD. So AD is going to be x plus y square plus h square square root, and cos theta is going to be x plus y, which is AC in this case, divided by AD, and that would be again divided by this term over here. So that's pretty straightforward now. Okay, so also in this question, we will try to use angle theta and angle alpha to find the relations between h and xy. Okay, so let me write down it in here. I'm going to use tan theta for ACD right angle triangle, which is the biggest one. So that would be h divided by, now that would be adjacent, right? So it's going to be x plus y. Okay, so from here you can subject h, that would be x plus y and tan theta. So this can be your first equation. Now we will use tan concept for BCD. Yeah, so it's going to be tan alpha. So it is going to be now h divided by x. So from here h is equal to x tan alpha, which is going to be the second equation. Okay, so now what we did was we used two triangles to find the h value. So alpha and theta both are involving in that case. So now from 1 and 2 you can see, so from 1 and 2 you can see h is equal to x plus y tan theta, and that is equal to x tan alpha. So this relation you can use for any of the question, and this you can keep as a way of doing trigonometric equations, way of solving trigonometric equations or trigonometric questions very similar to this with diagrams. Okay, so that's the purpose of this short video, and thanks.